first of all, you're doing something like something impossible that may never happen, you know? Because the mission to Mars is planned for 2030. It may be later because of the crisis and all things like that. Isn't it too early for such kind of experiments? So, what would you say?
You know, this is really great that we at least started to prepare, because of course this is really difficult project and really hard job to prepare everything, but it's really good that nowadays we at least turn our steps towards the red planet, and we are starting looking for solutions to solve lots of problems.
No, well, for you, it's I understand it's mainly a scientific interest, yes? I mean,
and professional.
And professional. And for you, Cyril, you're a professional pilot.
Right.
Well, for pilots, well, to fly, air is, well, I mean, it's everything. How did you just quit flying and get involved in such kind of thing?
Well, you know, it's a very fantastic and interesting experiment and experience. So.
But don't you miss flying? Or you do some flying?
Yet? No.
No.
I have to admit. Sorry for the French who are looking at the program. But this is a fascinating program. Going to Mars is a wonderful step way beyond what we have done so far, and it will definitely fetch a lot of scientific breakthroughs to the common people, to you, to me, to everybody who is looking at us.
You just told me that though you're both not young kids, but you think that by 2030 you'll be like around 60 and you may make it, you may really fly.
I guess
Do you really believe in it?
I will leave my seat for a second, I guess.
Well, will it require a pilot to take a spacecraft to Mars? Do you need to be a pilot to fly?
No, not really, actually. You have to be in good health, to have some scientific background, to speak a little bit of some languages that will be used in the mission, and be selected. That's it.
Does that mean you're more like guinea pigs? Or?
Not guinea pigs. It's, you know, the idea of the Mars flight and idea in this experiment that we're really a team of professionals, high-level professionals in our own fields, and we will be absolutely autonomous during flight, because if we will look for flight on the International Space Station, cosmonaut is able to call every second, to call to his managers, to his family, to scientists, to ask some questions. During Mars flight, there will be no such chance. That's why ground, so Earth, can only rely on professional crew members.
Okay, question to you as a pilot anyway. Well, the first phase of this experiment was a survival test in a winter forest. Is that true? Right. Is that where you're supposed to land when you're back from Mars? Into the taiga or somewhere?
Maybe. Who knows? And then that will be a training for that. No, it was more a team-building experiment, probably. And I guess we managed pretty well in
was the forest big enough to get lost?
We didn't go that far.
Honestly, that was really my idea, because I was, as commander of the crew, I was responsible for crew training. And taking in concern my experience during my cosmonaut training in Star City, I decided that, and advised to our head managers, that this is very useful team building part of training, and also self-checking for every crew member, just to see how each of us will act in really, really difficult conditions.
Because, you know, you put 4 Russians and 2 Europeans together, you have to make sure that they will go along well. And this is part of the test that may
without vodka.
Without vodka, definitely. We will come to that later.
Russians and Europeans go together very well if they have something to drink. Okay, well,
maybe later.
Out of all the planets in the solar system, Mars has proved to be one of the most intriguing. Spotlight's Yelena Demidova reports.
Mars fever started in the late 19th century. A number of scientific discoveries seemed to point toward the possibility of life on the red planet. One person who was obsessed with the idea was Herbert Wells, whose novel War of the Worlds contributed to the Mars mystery. Several years ago, Mars fever made a comeback after a sensational discovery: huge ice caps on the red planet's poles.
Mars indeed could have had lakes and seas and rivers, and that means that the environment was favorable for life to emerge on the planet.
A human mission to Mars could tell us more. The preparations are underway, but around 2/3 of unmanned spacecraft sent to the red planet have never returned. There is even talk of an Earth-Mars Bermuda Triangle.
But where there's a risk, there's always a hero. Those people who will eventually complete the 500-day mission to Mars will immediately find themselves in the Hall of Fame, next to these Russian pioneers of space exploration. This may explain why so many people are eager to take the risk.
Thousands have applied to take part in the Mars 500 program, which is being carried out in Russia. It's a simulation of a space flight. A team of 6 will be locked inside a model spacecraft to study how people cope with long periods of isolation and staged emergency situations.
If there's an emergency situation, we'll see it on the screen here, and then we'll analyze what happened and why.
Even though the preparations are in full swing, scientists still estimate we will have to wait for at least another 20 years to see the real Mars mission accomplished.
Well, it sure will take time and effort, but what's the point? What's the point of going to Mars? Say, is there any scientific, I mean, necessity of sending men?
You know, scientific is always behind it. And once again...
What's in front of it? What's in front? Curiosity?
It's probably the ability of mankind to go always beyond the limited frontier. And it happened during all the centuries before, in the past. And I guess it will continue in the future.
Sergei, you already participated in a human behavior in extended spaceflight experiment, yeah? What kind of experience did you get from this previous experiment?
I was participating in 1999 in a 1-month isolation experiment. That was before I was selected as cosmonaut. You know, that's really interesting experience to understand yourself better and to see how we are not noticing some small things during our usual life, like communicating with unknown people, information from TV, from newspapers, or just watching people in another car staying in traffic. People in isolation becoming hyper-emotional.
Really?
So a really small joke which can only make you smile, there will cause you laugh for 5 minutes. A little negative thing will make you really mad. And in science language it calls sensor deprivation.
Sensor deprivation.
Yes, so you're receiving really lack of incoming information. And that was really a surprise for me, and that's a huge lesson that I learned.
Are you ready for that, Cyril? As a Frenchman, I mean, isolation for French people, it must be very hard.
He's making me asking some questions. No, I'm kidding. You know, in your question, I feel like, are you afraid of going into that? Well, you know, fear is a kind of comparison between the ability that you think you have and the ability that you think you will need to overcome a situation. And if there is a big gap between them, then you start being afraid of meeting the requirements.
But you're gonna miss so many things. You're gonna miss football, foie gras, well, whatever.
You would say that for me when we exit. No, that's right. We will miss lots of things, but that's the point. And for a real mission, they will be missing lots of things, and for even longer. So, and we have to work on that psychological point of view.
And also adding danger, real danger for life.
Right.
So this isolation plus danger for life. So real mission will be even more difficult.
Say the cosmonauts Sergei Ryazansky and Cyril Fournier. Spotlight will be back shortly, right after break. We'll continue this interview in a minute, so stay with us, don't go. Welcome back to Spotlight. I'm Albernov, and just a reminder that our guests today are the cosmonauts and participants of the Mars 500 project, Sergei Ryazansky and Cyril Fournier. These are the two of the 5 people that will spend 105 days in complete isolation getting ready for a trip to Mars. By the way, do you think that if you make it, I mean these 100 days, will it be suffice to say that you will make it for a longer trip of 500 days? Is it enough?
I think it is. I think the most hard part is first 3 months. Then you're getting really used to the environment, to isolation. But of course it depends on personality. That's why we have so straight.
What's the language you're going to speak on board, Cyril?
Actually, 2 languages.
Russian.
Russisch.
Russian. So it's going to be Russian and...
Russian and English.
Well, there isn't a single Englishman on the crew. You have French and German.
Right, you're
Why
absolutely
English?
right.
Why English?
Because we are part of the European, we are volunteers from the European Space Agency, and one of the languages, most spoken languages in the ESA is English indeed.
But inside we have two Russian crew members barely speaking German. I will start learning French.
Learning French.
So,
what were the skills and professions required from the candidates when they were selected? Pilots, cosmonauts, who else?
I guess they may be different from the Russian and European point of view. From the European point of view, and I can speak about it, you had to be healthy, between 25 and 50-year-old, and so on medical conditions. Obviously, also some psychological requirements were required, but nothing really serious at the beginning. Then the selection starts.
How will the interaction between the crew, the isolated crew, and the flight control set be organized? Like TV cameras? What?
they always will have TV picture to have a look what's going on inside.
So it'll be sort of a Big Brother sort of thing, yeah? So they'll be watching all the time?
All the time, not all parts of the model, so it's not like Big Brother, it's not so. But the exchange of information will be mostly package exchange, so writing letters, reports, sending video files.
So no live conversations even with the control center?
Only at start of the isolation, like we're on orbit, we can discuss, and we still may have.
And when you might go further, it's going to be like emails, yeah?
Yeah.
Yeah, packages. What about communication with relative friends? Will you be able to send messages and get messages from your family?
On a real mission, you may be able to do so. We are, for the time being, it's not certain yet, but we are trying not to get into the personal relations so that we push the isolation a little bit forward and further. But obviously, as Sergei was saying, the more we simulate a real flight to Mars, and the more we advance, the further you go, and the more time it takes for a signal to go from one point to another.
But you should have at least some information. Well, you will never stand it. Well, I mean, if you come back, and realize that Lyon won the Champions League, and you knew nothing about it. I mean, you should have some, well, at least the big things they should let you know.
You're absolutely right. Like, Lyon being in the championship is a big thing, and I hope they will manage to send us the information.
Okay. We'll receive newsletters.
Newsletters.
We have a so-called psychology support team. They asked the fields of our interest, and they will make newsletters according to this.
So you will leave them a list of your interests.
Yes, we already gave, and they now already started working, collecting things and the sources of information, political or sports or something else.
Don't forget to put a point to make them keep you posted on how Sarah Palin is doing in American politics. And
her children.
That might be fun. I mean, if you can make people laugh, well, it's something you talk about. Okay, how large is the space? In isolation.
Not really large. It's like...
Don't give me cubic meters, not like square meters.
It's really hard. I was gonna give you cubic meters. We have 3 separate models. One living compartment, one biggest for storage and sport devices, and middle one, like smallest, it's medical and science module. Also, in the end of experiment, we'll have little tiny module that will be simulated Mars landing capsule.
Ah, the Mars landing capsule, okay. What are you going to eat? Are you going to grow something? Are you going to grow fruit, vegetables, broccoli, whatever?
We have greenhouses, but they will be more devoted to experiments. So we may try to grow some salads, but it will be on the side.
By the way, yesterday I learned that we will have something grown there specially to eat.
Really?
See,
No,
we are learning some
Please.
fresh news.
Les artichokes? You must take the seeds with you. You must smuggle some seeds. Okay, well, you can even grow grapes.
It will take time.
Makes
it will
wine.
take more than 105 days.
Okay, you don't have any women aboard.
No.
Is it sad for you? Well, like a pure male company, is it?
I think it's sad because it would be great to have different crew, but we still have one girl in our backups. She still have some chance, so she's still in training. Yes.
You want to say something about girls?
Yeah, there is absolutely no intentions beforehand to put girls or women on the side. It was not thought in advance to put only males.
But the reason that they made a decision to make a purely male team, is it because of the physical abilities of women, or because they think that the atmosphere will be better in a single sex team?
You know, we have too many physiological experiments, and man is simply organized physiologically. We're really easy for statistical data. Women, it really depends on physiological cycle, women physiology. That's why maybe scientists are demanding too much from women candidates, and they were not able to pass. But I know that many girls were applied from both sides, from ESA and from Russian side.
Well, Sergei does have some experience, and he surely was sharing some of it with you, Cyril. What do you think? What's the best recipe of not going nuts in such an isolated environment?
There are many tricks for not keeping us in a good shape. So I think the main thing will be to change the atmosphere sooner or later slightly. I mean, not always doing the same thing at the same time and with the same people. Monotony or getting used to something which may become a routine may be a big danger, and we have to avoid that.
If something goes wrong, if somebody's psychological condition or physical condition will be like endangered, will you quit? Will he be taken off the module, or you will still carry on for those 100 days, whatever happens?
Each volunteer has right to get out
to quit.
On wish, yes. But I hope that we will be able to notice such symptoms and to support our friend.
But you say it will be his right to volunteer, but is it going to be his decision? Or maybe if he goes a little bit nuts, go a little crazy, well, he would like to stay, and maybe others will see that he has to be taken away. Well, whose decision is going to be?
You're right. We never know what will happen. But, you know, we have a strong psychological training also from the Russian professor and teacher at the Moscow Academy. And these courses and lectures really helps us, really help us.
Sergei, have you ever thought, after you land in the taiga in the winter forest, and Cyril, I hope, will make a nice landing, how long will it take to adapt back to normal life, to a bigger world. Will this be a problem? What do you think?
Yes, it
Are you
will
getting
be.
ready for that too?
Because for now we have the most long duration flight was Valery Polyakov, 438 days, and the readaptation to Earth conditions is much harder compared with adaptation to weightlessness. Usually it takes like 3 months at least. Slight traces can be seen year and a half. So after Mars flight, we will have at least the same duration, like 500 days flight, 500 days rehabilitation.
Well, and last question. If you ever happen to fly to Mars, what do you expect to see? What do you expect from this mission, except getting a badge and saying, I went to Mars? Is there something special in it for you?
It's obviously special to go beyond the frontier that man has explored. It's obviously a very special mission. And, you know, once you are on the red planet, I guess you will see the sky differently, because the sky will not be blue. The ground will not be brown and green, and for grass it will be just red, so it will be difficult.
Okay, thank you very much, both of you, and please bring me a rock if you're ever going. Okay, thanks. Thanks a lot. Just a reminder that my guests today were cosmonauts and participants of the Mars 500 project, Sergei Ryazanskiy and Cyril Fournier. That's it for now from all of us here. We'll be back tomorrow with new opinions on what's going on in and outside Russia. Until then, stay on RT and take care.
Ich bin Oliver Knickel aus Deutschland. Ich bin 28 Jahre alt und vom Beruf Ingenieur bei der Bundeswehr. 2002 war ich für 3 Monate im Afghanistan-Einsatz. Zu 100% kann man das natürlich nicht vergleichen, aber monatelang mit denselben Gesichtern im gleichen Zelt, das übt.
Oliver ist einer von nur 2 Freiwilligen aus Europa, 2 von mehr als 5.600 Kandidaten, die bei einer internationalen Simulationsstudie mitmachen wollen. Ziel sind mehr Erfahrungen über das Bordleben in einem Mars-Raumschiff. Der für den Ablauf unerhebliche Standort des Experiments, das russische Institut für Biomedizin IBMP in der Nähe von Moskau. Die Europäische Weltraumagentur ESA ist mit an Bord. Zurzeit bereitet sich ein Team auf 105 gemeinsame Tage vor. 4 Russen und 2 Westeuropäer lassen sich für gut 3 Monate einschließen in die Isolierkammer, die eine Raumkapsel simuliert. Das Sauna-Interieur vielleicht ausgenommen. Volle 520 Tage Bordleben sind dann die nächste Etappe.
Ich bin Franzose, 40 Jahre alt und heiße Cyril. Ich fliege einen Airbus A320 und habe mich bei der ESA für das Experiment beim russischen IBMP beworben. Das hier ist eine Herausforderung. Wie kommt man 105 Tage lang mit 5 anderen klar, auf engem Raum und unter erheblicher Arbeitsbelastung? Die hautnahe Vorbereitung einer solchen Weltraummission ist interessant, auch wenn bis dahin noch Jahre vergehen. Ich hoffe, dass eines Tages tatsächlich Menschen zum Mars fliegen.
Eine bemannte interplanetare Mission würde eine umfassende Zusammenarbeit vieler Länder voraussetzen. Auch die Crew wäre vermutlich international und hoffentlich stressfest. Superschwerkraft beim Start, Schwerelosigkeit, kosmische Strahlung und monatelange Isolation, das steckt keiner so leicht weg. Was will Mars 500 erreichen? Erfahrungen sammeln über die Psychoeffekte einer Langzeitklausur. Sie sollen helfen, ein wetterfestes internationales Team zusammenzustellen.
Ein Überlebenstraining im Winter, das haben wir schon hinter uns. Bis zu 27 Grad minus 30 Kilometer hinter Moskau. Die Vorgabe, wir steigen im russischen Wald aus der Landekapsel und halten durch, bis uns nach längerer Zeit jemand findet.
Im Ernstfall müssen sich unsere Marsflieger in ihrer Kapsel unter Echtbedingungen selbst helfen. Möglichst wirklichkeitsnah sind auch die eingeschränkten Außenkontakte. Das Team muss Gesundheit und Psychozustand der einzelnen Mitglieder selbst im Auge behalten.
В изоляции, а опыт в Институте медико-биологических проблем таких экспериментов значителен.
Isolation erzeugt eine ganz besondere Gruppendynamik. Das wissen wir aus ähnlichen Studien seit den 60er Jahren. Komplexe körperliche und psychische Wechselwirkungen erfordern mentale Unterstützung und Korrekturmechanismen. Jeder muss ein inneres Gleichgewicht entwickeln, um in spannungsgeladenen Situationen angemessen zu reagieren.
Super interessant. Ohne Probleme wäre das doch ein langweiliger Spaziergang. Wir machen uns auf Spannungen gefasst, auf Störungen im Schlafrhythmus und Anpassungsschwierigkeiten in einer abgeschlossenen Umgebung. Kaum Platz, keine Fenster, aber das ist es, was zählt.
Natürlich wissen alle, dass unter ihren Vorgängern auch schon einige ausgeflippt sind. Einer floh sogar nach 60 Tagen aus der Kapsel. Und überraschend werden während der simulierten Reise auch Krisen von außen eingestreut, wie im wirklichen Leben im All.
Les facteurs psychologiques aussi se mettent en place.
Man kann nicht raus, der Kontakt zur Erde ist erschwert. All das fordert psychisch seinen Tribut. Mails oder Telefongespräche brauchen über die Distanz 20 Minuten bis zur Erde.
Liebevoll wird auch dieses Detail nachgestellt. Unsere Verbannten in ihrer Kapsel können nur in lähmender Langsamkeit mit der Außenwelt kommunizieren.
Von dieser Kontrollkabine aus kommuniziert man mit der Erde. Man kann sich das in etwa so vorstellen wie in einem Internetchat auf der Erde, nur dass jede Botschaft erst nach 20 Minuten beim Empfänger ist.
Wissenschaftler verfolgen über allgegenwärtige Kameras das Geschehen an Bord und analysieren zeitnah Aktionen und Reaktionen der Raumfahrer.
We will have from this very room contact to the crew.
Von hier aus halten wir mit der Crew drinnen Kontakt per Video. Stimmaufzeichnungen und Übertragungen von Messwerten. Alles 20 Minuten verzögert, wie bei einer echten Reise zum Mars. Das belastet alle, aber sonst wäre die Simulation nicht realistisch.
Die Erkenntnisse aus Mars 500 sind für alle möglichen wissenschaftlichen Untersuchungen von unschätzbarem Wert. Die Forschungsfelder Stress, Hormonhaushalt, Schlafgewohnheiten, Stimmungsschwankungen, Kunstlicht und Spezialnahrung.
Wir haben aus einer Riesenzahl wissenschaftlicher Anfragen einige herausgefiltert. Die europäischen Wissenschaftler haben die Versuchsanordnungen in den vergangenen Wochen mit der Crew diskutiert und vielfach auch eintrainiert. Die europäische Forschergemeinde erwartet hier einen bedeutenden wissenschaftlichen Impuls. Wir sind alle sehr neugierig, das kann ich Ihnen sagen.
Menschlichen Besuch auf dem Mars halten Fachleute in gut 20 Jahren für machbar. Jetzt ist also der richtige Zeitpunkt, um für kommende Jahrzehnte Wissen und Möglichkeiten zu bündeln, bis die ersten Erdbewohner zum roten Planeten fliegen und dort vielleicht eine Zweigstelle eröffnen.
The first manned flight to Mars takes a major step forward next week. 6 volunteer astronauts from Russia, France and Germany will take part in an experiment to see if human beings would be able to withstand the 2-year journey to the red planet and back. They'll spend the next 3 months sealed inside a capsule in Russia, as Richard Galpin reports from Moscow.
For human beings to reach Mars has been a dream of decades. But so far, only machines have touched down after the flight, which lasts almost a year. That's why the experiment here in Moscow is so important. The volunteer astronauts will be locked inside these mock spaceship modules until July to test their endurance. We were allowed a glimpse of what it'll be like. Now, whilst on board, the 6 volunteer astronauts will be kept extremely busy. At the moment, of course, it looks pretty bare and empty, but by the time the experiment starts, it'll be filled with scientific equipment. So the astronauts can carry out a whole series of tests, and of course, they'll have to make sure that all the onboard systems continue to function normally. This is the spaceship commander, Sergei Ryazansky. Will they all cope with the isolation?
Definitely it will be not fun. Each volunteer, each test subject has this right to go out at any moment.
This is the volunteer Cyril Fournier, a pilot from France.
You have to cope with the environment. That's the main point. I mean, you can be psychologically normal, but some people may be claustrophobic or may fear that, I don't know, something may happen. It is not my case.
The results of this test could help make the first human flight to Mars a reality. An extraordinary leap forward, which may happen in little more than 20 years' time. Richard Galpin, BBC News, Moscow.
Reise simuliert. Während des Langzeitexperiments haben sie einen Container bewohnt. In ihm sollten Bedingungen für eine echte Mars-Mission getestet werden. Heute durften die Teilnehmer ihre enge Behausung im Moskauer Institut für Medizin und Biologie wieder verlassen. Einer von ihnen ist ein Offizier der Bundeswehr.
Explains. After 105 days, the seal is broken and the lock undone. Moments later, the 4 Russians, 1 German and a Frenchman step out of the capsule into the light of dozens of flashing cameras, apparently none the worse for wear. Their capsule had in fact never left the ground, but everything inside was designed to make them feel as isolated as if they were on a real trip to Mars. The capsule is Spartan and cramped, to say the least. There are no windows, and the radio communication with ground control was deliberately delayed by up to 20 minutes. Speaking to the media afterwards, the Russian commander of the mission declared it a complete success.
This experiment was really a cooperation between many scientists, and it was also a cooperation within the crew. Mutual assistance and support were evident at all times.
But even 105 days is not nearly enough to get to Mars and back. So next year, another group of volunteers will enter this same cramped capsule and be sealed inside for a daunting 520 days. That's nearly a year and a half. Rupert Wingfield-Hayes, BBC News in Moscow.
Es ist 14 Uhr in Moskau, als Oliver Knickel erstmals wieder Tageslicht sieht. 105 Tage ohne Dusche, ohne Privatsphäre und ohne Sonne liegen hinter ihm und seinen Kollegen.
Ich bin sehr gut gelaunt, also in keinster Weise, dass ich mir denke, jetzt bin ich endlich draußen, froh, dass es vorbei ist. Also es war eine sehr gute Erfahrung.
Seit dem 31. März war Oliver Knickel gemeinsam mit 5 weiteren Testastronauten in dieser engen, naturgetreuen Kapsel eingepfercht. Dabei führten sie eine Reihe von Experimenten durch. Vor allem der psychische Druck, monatelang auf engstem Raum ohne Fenster forschen zu müssen, stand im Fokus.
Ich war selber verwundert darüber, über andere Dinge, sei es Ernährung, sei es die Sonne, Natur, wie sehr schnell ich mich auch doch daran gewöhnt habe, dass diese Dinge eben im Modul selber nicht vorhanden waren.
Die einzige Verbindung zur Außenwelt eine Videoleitung in die Zentrale. Kommunikation getreu dem Ernstfall mit 40 Minuten Verzögerung. Ein Experiment, das die Forschung dem großen Traum eines Tages, die 55.756 Millionen Kilometer zum Mars zu fliegen, einen großen Schritt näher gebracht hat.
Oliver Knickel hat sicherlich durch seine Beteiligung für einen wirklichen Marsflug, der vermutlich erst in, 30 Jahren vielleicht sogar erst stattfinden wird, einen wichtigen Beitrag geleistet.
Ein Beitrag, bei dem die Freundin ihn stets unterstützt hat.
Also ich kann nur sagen, diese 3,5 Monate auf ihn zu warten, das war eine große Ehre für mich. Und ich werde auch länger, wenn es sein muss, ich werde auch länger auf ihn warten.
Denn die echte Reise zum roten Planeten würde 520 Tage dauern. So war die aktuelle Studie nur der Vorläufer einer vollständigen Marsflugsimulation 2010. Vielleicht ist Oliver Knickel dann auch da wieder dabei.
This is the Mars 500 project, a joint Russian and European experiment simulating an epic 500-day journey to the Red Planet and back. On board, an international team of 6 volunteers has been living in isolation, trying to assess some of the difficulties a future mission to Mars could face. All right, well, here we are inside the Mars 500 simulator, and we're joined by one of the participants, Oliver Knickel. He's from the German army. He's been on board this experiment for the past, 105 days?
105, yes.
Oliver, where are we now? This looks like the food store.
Yeah, this is the storage module, and this part of the storage module is occupied by the food. And as you see here, it's our baby food.
Baby food, is this what you ate?
Yes, but I mean, there are no other possibilities. If you go on a long-term space flight, I mean, you only can eat the food which you take inside from the very beginning.
Yeah, obviously, yeah.
And you can't grow a big amount of fresh food inside the spaceship.
But you grew some fresh food?
We did, yes, we have a greenhouse.
Let's have a look. Yeah, open them up.
We grew quite some stuff in it, among it radish, strawberries, pepper.
Chili peppers.
Chili peppers, yes.
Well, one of the most important things when you go on a long mission to Mars is to stay in shape. But of course, you can't use dumbbells. In zero gravity, that doesn't work. And so you've got to have special bits of equipment like this. OK, here we go. Oh, jeez. God, it's not very it's not very elegant, is it? Getting through one of those holes. But Oliver, this is obviously the dining area.
Yes, the kitchen and the dining area also. Mm-hmm.
How difficult was it living in such a small, cramped environment with these people for so long?
Actually, you get kind of used to it kind of quick.
But I mean, inevitably, you must have got annoyed with each other.
Yes, but we were kind of selected also for being psychologically stable and
being nice,
more or less calm.
Spirit ist auf dem Mars so weit von der Erde weg, dass ihre Funksignale zu uns eine halbe Stunde unterwegs sind. Und jetzt ist Spirit in Schwierigkeiten, aber Spirit gibt niemand so leicht auf.
Verdammt weit weg ist der Mars, wenn man einem helfen will, der dort im Sand feststeckt. Mehr als 100 Millionen Kilometer. Seit Monaten haben Forscher am Modell an Lösungen getüftelt. Heute schicken sie Spirit die Kommandos, mit denen sie sich aus eigener Kraft befreien soll. Obwohl Spirit dort schon eine ganze Weile festsitzt, ist sie nicht untätig gewesen. Sie hat uns mit ihren Instrumenten geholfen, das Material zu untersuchen, in dem sie feststeckt. Und das ist absolut faszinierend. Wir finden da den bisher besten Beweis, dass es dort Wasser gegeben hat. Seit mehr als 2000 Marstagen kurft Spirit auf dem roten Planeten herum. Sie hat mittlerweile mehr als 7 Kilometer zurückgelegt und sogar eine Hügelkette erklommen, die vorher als unbezwingbar galt. Einer hat Spirits Schicksal mit besonderer Anteilnahme verfolgt, Gösta Klingelhöfer. Eines seiner Messgeräte ist mit auf dem Mars. Für den Forscher eine Zitterpartie, zumal Spirit seit langem nur noch rückwärts fährt. Ein Vorderrad dreht sich nicht mehr.
Der Defekt mit dem Rad hat den positiven Aspekt, dass quasi beim Fahren eine Furche automatisch gezogen wird. Und da sind sehr wichtige und entscheidende Informationen und Proben auch gefunden worden.
Mehrere stürmische Marswinter hat der Rover ohne Schaden überstanden. Jetzt wird ein Sandloch Spirit zum Verhängnis. Sie wird es schwer haben, herauszukommen, wissen die Forscher. Sie können nur abwarten, ob sie es schafft.
Es ist natürlich eine traurige Sache für uns. Seit über 6 Jahren sind wir jetzt auf dem Mars aktiv aber wir haben natürlich innerlich immer gewusst, dass so ein Moment kommen wird, dass er dann dort sein Rovergrab finden wird.
Wenn nicht doch noch ein Wunder geschieht. Und Wunder hat es bei Spirits Mission schon viele gegeben.
Wir fanden gerade, dass sie wirklich aussieht wie E.T., wenn sie da so mit ihren kleinen Augen über den Mars fährt. Also Spirit, call home.
Was als 3-monatige Mars-Mission
Good evening. We are going to concentrate now upon the red planet Mars. First of all, Mars is a planet smaller than the Earth. I've got 2 globes here to show that. There's
there we
Mars,
go. I'll give you Mars.
Thank you, Pete.
And there's
and
the
I'll
Earth.
be the Earth.
As you can see, Mars is much the smaller of the two. But that means it hasn't got so much gravity. It doesn't pull so strongly. It's got less air. And also, because it's further from the Sun, just over 141 million miles, it's colder than the Earth. So we certainly couldn't live there unaided. Nevertheless, Mars has always been the world regarded as the possible abode of some kind of life, and we're still not sure. So there's Mars. Now, having found it, what about using a telescope? You don't need a large telescope, even with a small one, such as my lovely 3-inch refractor. You can pick up detail. Here's the drawing I made with it.
Yes, I found this in your slide room. This dates back to 1952. And with your 3-inch reflector, you've got some evening clouds on the terminator here, and of course the prominent Syrtis Major marking. And a bit later on, with your 5-inch Cook refractor, here's the drawings you made of the Solis Lacus region on Mars.
Now, may I look at one of your drawings, Paul?
You can, certainly. Here we go. This is one I made fairly recently, on the 27th of January. And the Acidalian region is quite prominent, as is the North Polar Cap.
So let's make out just what these features are. First of all, the polar cap. That looks like ice or snow or frost. It's exactly what it is. It's mainly water ice. Expect that. Here we have dark markings, once thought to be seas. But you can't have seas on Mars. There's not enough air. So we now know they're not even vegetation. And that's quite a new discovery, isn't it?
It is, yes, absolutely. The complexity of this region is quite fantastic as well, and you can see when you look at it.
It really comes out well in an eyepiece, but you really need the good seeing to get those fine, tantalising
But
details.
these fine lines which you can see there, you can actually understand why people probably thought there was actually civilization there building something on the surface of Mars.
And of course they change over time.
They do.
Because of the weather, the dust it blows.
We've basically got the sort of lighter regions are the sands of Mars, if you like, the desert areas, and
Yes,
they
indeed.
shift with time, don't they, as the wind blows.
And of course, the seasons are long. Mars goes around the Sun in 687 Earth days, a long year, but its day is half an hour longer than ours, so not all that different.
And that's really quite frustrating as an observer of Mars, because when you look at it and then you go out the next day and see it again, you see a little bit round, and then you get a repeat of what you saw the previous
Takes
night.
ages to build up. This is about 3 or 4 weeks before you can see the whole Martian surface.
That's
in fact,
right,
isn't
yeah.
it?
So basically, the polar cap is icy. The dark areas are places where the red, dusty stuff has been blown away.
Yes.
And those red areas are deserts, but of course they're not like our deserts. No palm trees and camels there.
Definitely not.
They are cold.
They are very cold. And in fact, one of the nice things I think you can see through a telescope, and it really emphasises just what a dynamic, fascinating world Mars is you get these morning and evening clouds over the desert.
they're beautiful, aren't
and
they?
when
Really
they collect
good, yeah.
around the volcanoes in the Tharsis region, you get this weird W-shaped clouds. It really brings it home to you that this is another world in space.
I completely agree.
It's a fantastic sight.
Well, we're looking at Mars for over 60 million miles, and always from over 30 million. What we need are rocket probes, and they've been sent there. Some have landed, some have orbited, and we had those 2 splendid rovers, Spirit and Opportunity, crawling around Mars and sending back the most amazing data. Spirit's tail is now stuck, but they've done their work. And Chris, been to America, talking to the key man of the whole program, Professor Steve Squires. And so now, over to America.
In January 2004, two remarkable rovers touched down on the surface of Mars. Spirit and Opportunity were only supposed to last for 90 days, but 6 years later, they're still going strong. The rovers are essentially robotic geologists that can move around, take pictures, and analyse rocks to determine their composition, and so build up a picture of the Martian landscape. Spirit landed in a large crater called Gusev, left over from a long ago meteorite impact. On the other side of the planet, its sister, Opportunity, landed on the plains of Meridiani. Both sites were selected as they looked, at least from orbit, to be likely places to find evidence that Mars was once a warm, wet world. Spirit was the first to land, but quickly discovered that the surrounding rocks were volcanic and had little to say about water. So the rover headed off to the more promising-looking nearby hills. Opportunity, though, hit the jackpot. Right in front of it was an exposed rock face, bedrock, that clearly showed evidence of water. Critically, this is evidence that Meridiani was once a lake or a sea of liquid water, right here on the red planet's surface. Meanwhile, Spirit had heroically climbed up Husband Hill, finding evidence that here, too, water was once common. Opportunity had been travelling too, first reaching nearby Endurance crater, and then heading off across the sand dunes to a much bigger crater, Victoria. Steve Squires has dedicated his career to build spacecraft to land on Mars, and he's led his team on this epic 6-year journey. We started talking where we'd left off on his last Sky at Night appearance, with Opportunity's arrival at Victoria Crater.
Victoria's about 800 meters in diameter, and about 70 meters deep. It's got cliffs on the crater walls that are vertical in places and can be as high as 6, 7, 8 meters. So it's a dangerous place. I mean, it's the kind of place where if we make a mistake, our little rover could fall off a cliff and die. So when we were operating along the rim of Victoria, we had to do so very, very carefully.
Why is Victoria Crater special?
Well, Victoria was the deepest hole in the ground that we had access to. You know, we didn't bring dynamite, we didn't bring a drill rig, we have no way of looking below the surface other than what, you know, looking at the holes that nature has dug for us. And at the Opportunity site, getting below the surface is particularly important because the rocks there are sedimentary rocks and they're flat-lying, they're layered, okay? And the terrain is very flat, and so if you're driving along the surface, you're basically just seeing the same layer over and over, and you don't know what lies beneath.
And that means you're looking at the same time in Mars history.
You're looking at the same time in Martian history, you're looking at a record of the same environmental conditions in Martian history. You're basically doing the same thing over and over. If you can get below the surface, you go back in time. And Victoria is this huge big hole in the ground.
You did a very long exploration of the rim.
Yeah, we spent nearly a year working our way along the rim. So what you have are these kind of alcoves, and they're just tens of meters away is a cliff.
And so you could do lots of your science.
Exactly. There's like 6 meters of vertical rock there to be imaged. But this is the tricky part. To get the shot you want, to get the image that you want, you need to drive right to the edge. So there was this incredibly intense year where you've got the rover drivers, the engineers, whose job it is first and foremost to protect the vehicle at all costs. And then you got the scientists saying, just go a little closer to the edge. Just go a little closer to the edge, you know. And there were times where literally we practically had the front wheels hanging over the edge of a cliff to get the shot that we wanted.
Were you always going to go inside the crater? I remember a lot of debate at the time, because what if you got stuck in there? That's it.
Yeah, we went back and forth on that for a long time. Were we going to go in and take the risk or not? You know, the science return from going in is obviously important because many of our instruments, you have to reach out and touch the rock.
That's
right?
What the
so you got to go down. Yeah, all the instruments on the arm, you got to go into the crater if you want to take advantage of this big hole that we're exploring. But there's the risk that you're not going to get out again. The good thing was that by the time we got to Victoria, we really had a very good handle on what we could do and what we couldn't do. We had operated it on steep slopes before. We were confident enough that we could pull it off.
And so you shuffled down slowly into the crater.
What you do is you're kind of working your way back in time geologically as you go to deeper and deeper and hence older and older layers. And we would just work our way down. And each time we got to a layer that looked different, we would take the instruments on the arm and we would use them to characterize the texture, the chemistry, the minerals that are present, and so forth, and just work our way down into the crater, doing a stratigraphic section. And the thing that was beautiful about that, you know, geologists are big on doing stratigraphy, and a stratigraphic section is just a description of the rocks in a vertical sequence.
As you work downwards.
Exactly. And, you know, we were incredibly proud of the fact that over at Endurance Crater, the first half year of the mission, we did the first stratigraphic section that had ever been done on another
not just
planet.
picking up random rocks on the surface anymore.
Yeah, we're working our way down very methodically. But now we could do two different vertical stratigraphic sections 6 kilometers apart at Endurance and Victoria, and compare the two to look at lateral variations.
So what story did the rocks in the crater tell you?
What they told us was that the rocks there, as they were at Endurance, are sandstones. The grains of sand are made of largely sulfate salts that were formed when acid groundwater evaporated away and left these sulfates behind. Blown around by the winds, we see marvelous, oh gosh, some of the pictures are just fantastic. In the walls of the crater, we see the ancient remains of very ancient sand dunes that were once present, and you can see that it's called cross-bedding, where there are layers that meet at angles like this, and it's just like from a geology textbook. It's just absolutely fantastic stuff. And then, after the rocks were deposited, they interacted with liquid water below the ground, dissolving away some minerals, precipitating out others, and so forth. And the patterns are very similar to what we saw back in Endurance. So what that says is that it really was regional.
Was climbing out? Did things go as expected?
It was tough at first. The initial parts of the ascent out of the crater, we had a lot of wheel slippage and spinning, and there were a few kind of white-knuckle days in there where we were a little nervous. But we eventually did get out of the worst of it and got back on ground where we had good traction, and out we went.
And then what?
Well, that was the interesting thing. The obvious easy thing to do is just kind of go, you know, noodling around on the plains till the wheels fall off. Or we could try something a little more bold. And more than 10 kilometers off to the southeast, in fact closer to 20, there is this huge crater that we named Endeavour Crater. We can see the rim of Endeavour Crater on the horizon from where we are right now. We could see it a year ago.
And because it's huge.
It's huge. It's absolutely huge. The rim is hundreds of meters tall. 25 kilometers in diameter, hundreds of meters deep. It's not even a crater that was formed in the layered sedimentary rocks. It's an ancient crater, huge thing that predates those sediments, and the sediments were deposited over top of it, and then there's bits of the rim sticking up through the crater. So it's really, really different. And we decided we got to pick some direction to drive. Let's go for that thing. We were talking about more than doubling the total mileage on a 5-year-old vehicle that was designed to last for 90 days and go a kilometer. Let's just say that the odds were not in our favor, okay? But it has just energized the science team, the engineering team. Opportunity is just a fun vehicle to operate these days.
Well, let's swap sides of Mars. Spirit?
Spirit has had a tough time, and about 800 days into our 90-day mission, the right front wheel on Spirit failed. The motor just simply will no longer turn. And unfortunately, the way these motors work, it won't freewheel. It's not like the wheel will just turn by itself. It's just it's an anchor, okay? And we have to drag it. So Spirit, which used to climb mountains and drive 100 meters in a sol on a Martian day, a really good day would now be 5 meters. And we have to drive the vehicle backwards, dragging the dead wheel through the soil, and it was painful. So one day we're driving along through this little valley, dragging our dead wheel. We get to the end of the drive, and we look down at the wheel tracks, and they're as bright as white snow. So that got our attention. We go over, we whip out our X-ray spectrometer, we measure the composition of this stuff. It's 91% pure silica, SiO2. Now, this is not quartz. This stuff is not beach sand. We can look at it with our infrared spectrometer, and what we see is that it's not crystalline material at all. It's an amorphous material. It's basically opal. And there's lots of it. And we never would have seen it if it hadn't been for the dead wheel. That was what exposed it. So we then looked around and found that some of the rocks were made of this and so forth. Anyway, long story short, what we've come to realize is that these silica deposits are the remains of an ancient hydrothermal system. There are two ways that you can actually make concentrated silica deposits like this. One way is if you have water that has kind of a neutral pH, it's below the ground and it gets hot. It turns out the neutral pH silica is one of the most water-soluble components of rock. And you can dissolve silica out of the rock and it goes into solution in the water.
And if you heat up the water, you can get more silica.
Right, the hotter it is, exactly.
Just like cooking,
that's
right?
an
If you want
important point.
salt
That's a very important point. It's the hotter it is, the more it can hold. So very hot water picks up lots of silica. The water's hot, so it's buoyant. It rises to the surface. It gets up to the surface where it's cold. It cools. And now it can't hold all that silica anymore, so it precipitates it out. If you go to a place like Yellowstone, where the geysers are, and you look around the geysers, there are these beautiful sort of whitish, bluish rocks around them. Those are silica that have been precipitated out of the water. The other possibility is that rather than being hot spring deposits, these are the remains of ancient, very acidic volcanic fumaroles. But in either case, whether it's fumaroles with acid steam or whether it's hot springs, these are indicators of water and hot rock interacting with one another. There was a hydrothermal system here, and you can go to hot springs on Earth, and you can go to fumaroles on Earth, and in either case, they're teeming with microbial life. So this was the remains of an ancient hydrothermal system, an ancient habitable environment on Mars, and we found it because of the dead wheel.
So where's Spirit now?
Spirit's stuck. We lost that right front wheel, and frankly, the fact that we managed to continue the mission for another 1,000 Martian days with a bad right front wheel was miraculous. We were living on borrowed time as soon as we lost that wheel. But then the right rear wheel failed. So now we got 4 wheels. And 2 dead wheels, that rover ain't getting out. So unless some absolute miracle occurs, Spirit has found its final resting place on Mars. And we transition from being a rover mission into being a lander mission. Now, it turns out, actually, that there are some classes of science, including some science that's very important, that you can only do with a stationary vehicle. My favorite one is something that we don't do with any of our instruments. It's something we do with the radio system on board the vehicle. If we very, very precisely track the radio signal from one of our vehicles, and if the vehicle's not moving, then what you can do is you can trace its motion so precisely that you can actually very accurately determine the orientation of the spin axis of Mars. You'll see one kind of wobble if Mars has a liquid core of iron, and you'll see a different kind of wobble if it's got a solid core. That'd be a kind of neat feather to add to our cap at this point.
Let's go back to Spirit, though. It must hurt to have the rover stuck.
I think the day when it suddenly hits us, we've gotten our last transmission from the vehicle. That's going to be, I think, pretty hard. There have been 1 or 2 times over the course of the mission where, major dust storms particularly, where it looked like the power system was just getting so ragged that we were going to lose the vehicle. And so the most likely way in which a stationary vehicle dies is too much dust on the solar arrays, seasons change, and we lose power. We can't keep the thing alive. And I don't anticipate that's going to be a good day. It's had a good life, a good, long, productive life, and it's achieved so much more than any of us could ever have anticipated or hoped for that if this is the end, it is clearly an honorable death.
Before Spirit can start its new life as a stationary laboratory, it has to survive the harsh Martian winter, which is likely to send the rover to sleep for weeks or even for months. On the other side of the planet, opportunity is still going strong. It's only just visible amongst the sand dunes on this image, captured from space by the Mars Reconnaissance Orbiter. It'll be a long, hard slog, but 7 miles and thousands of sand dunes away lies her target, Endeavour Crater. Let's hope she makes it.
Chris, welcome back from America. I wish I'd been with you. News notes. I'm going to start this time. Prometheus, that strange little moon of Saturn, imaged here by the Cassini probe, still going around Saturn. This is a remarkable picture.
It is, not only because it shows Prometheus, as Cassini passed 40,000 kilometres from the moon, but look in the top left, you can see these little coloured features, and these aren't the moon at all, these are rainbows. The light has passed through the icy particles in Saturn's moon, and you've got rainbows scattered across the surface. It's a remarkable sight.
It certainly is. Now let's go beyond the solar system. That's your field.
Sure. Well, let's start with a new star that's been discovered, and pretty close to us as well, between 10 and 50 light years away. This is a brown dwarf, and it was found by astronomers using the UK infrared telescope in Mauna Kea in Hawaii. And they're doing a survey looking for stars like this. And this one's particularly special. It's orbiting another brown dwarf, but it's the coldest star that we know of. In fact, it's cooler than the top temperature in my oven. It's about 227 degrees centigrade. So it's extremely cold for a star. There must be some sort of reactions going on in the centre to power it, but nothing sustaining. It's almost the failed embers of a star.
It never really got going.
Yeah, I think that's a fair description.
Right. Let's go further out now.
Yes, right to the edge of the observable universe in this remarkable new image from the Hubble Space Telescope. What you're seeing here is a picture of almost the very first galaxies. The Big Bang, we think, happened almost 14 billion years ago. These galaxies are seen as they were 700 million years later. So that's really very early. And what's interesting is the galaxies are smaller. They're about a 20th of the size of the Milky Way, about a 100th of the mass.
But they contain stars.
Yes, and ordinary stars as well. Stars that have heavy elements, which means there must have been a previous generation of stars first. And that means you're pushing the date for the first stars back to something like 400 million years after the Big Bang. And that's a lot earlier, I think, than most people would have expected. There's something really unexplained about the early history of star formation. And we'll probably need many more years and a telescope bigger than Hubble to take us back right the way to the first stars.
I'm sure we will. And finally, what about Herschel?
Yes, well, this is the largest telescope in space, of course, the European Space Agency's infrared satellite. I'm pleased to report everything's going really well, and we're beginning to get the first scientific images. So you're familiar, of course, with the Rosette Nebula.
I am indeed.
You have this cluster of hot young stars that are surrounded by gas that's left over from when they were made. And what you see in this marvellous Herschel image, and by the way, the colours tell you about temperature, so blue is hotter, red is colder, so you can see the gas is being heated by those young stars, but deep within them you can see these red points of light, and they're newly forming stars. So another generation of star formation in the Rosette.
Discovery is coming thick and fast. Chris, thank you very much. Good night.